The last problem in this section is example 7. The annual interest rate on a credit card is 24.99%. If a payment of $100 is made each month, how long will it take to pay off a balance of $2,487.56? Assume that no new purchases are made with the credit card. Okay. Here is another real life example. Okay. So, we all have credit cards. Okay. And, we charge things and we build up our balances. And you know that when you pay off your credit card, you have a couple of options every month. You can either pay off the balance or you can make the minimum payment. Okay. So, what this example is helping you calculate is if you have a balance run up on your credit card, okay, and the balance here is $2,487.56, and you choose to make the minimum payment each month, okay, we're going to try to figure out how long it's going to take to pay off this outstanding balance, okay. Something that is maybe not as realistic here is that you're not making any additional purchases, okay. So I kind of think of this problem as maybe like a furniture store credit card where you're making this bigger purchase, but you wouldn't be making any additional purchases. So maybe you can think of it that way. You might be wondering about the interest rate here. It is pretty high. It's 24.99%. That is very realistic. If you look at clothing stores, that's a big one. Clothing store, furniture store, those kinds of things. You're going to see interest rates up to this amount. I mean, that's really hefty there. Okay. The next time you get something in the mail, like one of those credit card things they send you in the mail, and they're like, sign up. Look at the interest rate. Okay. Pay attention. That is very, very steep. Okay. All right. Let's talk about how we're going to solve this problem. Because again, we're trying to figure out if we made the minimum balance or made the minimum payment on our credit card, okay, $100 a month, that's all we can afford. How long is it going to take us to pay off this balance? Okay. Well, when you read this, you're probably immediately thinking, okay, this is a debt problem. I'm paying off a debt. Okay. So let's write down our amortization formula because you are correct to think that. Here's our amortization formula. Okay. Let's talk about what we're solving for here. Okay. Where did my, all right. So here's the formula. Okay. Again, we are trying to figure out how long will it take to pay off the balance. Okay. So we are solving for time. Okay. When you look at this formula, okay, your amortization formula, where is time located? Okay. Time is located in the exponent, which is always a bit challenging, okay? But even trickier with this formula, it's in the exponent in the denominator, okay? So that brings a whole nother level of challenge here, okay? So yes, you could use this formula, okay? But it's going to be especially tricky because time is not only in the exponent, but it's located in the denominator, okay? So your best bet for solving a problem like this is to use the equivalent formula, okay? Remember when we talked about the amortization formula, okay? We said that it was equivalent to the present value of an annuity formula, okay? So I'm actually going to use that formula to solve this problem because they are equivalent formulas. And while time is still in the exponent here, at least it's in the numerator, okay? So that's going to make it a little bit easier, okay? So my preference here is to use the present value of an annuity formula, okay? So I'm going to go back to this and I am going to erase this, okay? So we're going to write down instead the present value of an annuity formula just because time is in the exponent or is in the numerator here, and that makes it a bit easier, okay? So let's go ahead and write this down. We're still solving for time. All right, so let's go ahead and write down everything else that we know. Okay, so we're looking for time. Okay, Our interest rate is that very steep interest rate of 0.2499. Okay. Let's see. You're making monthly payments. Okay, so the interest will be compounded on your account monthly as well. Okay, so M is going to be 12 here. Okay, we need to figure out PV and P. Okay, so those are the two outstanding variables we need here. Okay, remember when you think about this formula, okay, we said that if you use the present value of an annuity formula and you use the amortization formula, if you use those two guys interchangeably, present value and debt are equivalent. Okay, so the present value here would be equal to your debt. You're in debt $2,487.56. Okay, so that would be the PV value here. And then P is the amount of money, the regular payment you would make to pay off your debt. Okay, so you're making regular payments of $100 here. Okay, so that's how you would, those are the identifications of the remaining variables. Okay, so let's go ahead and plug all of this in. Okay, again, it's going to be a bit challenging because we're solving for time and time is in the exponent. Okay, but let's start by plugging everything in. Okay, so we're going to have $2,487.56 is equal to 100 times 1 minus 1 plus the interest rate divided by 12 raised to the negative 12 times t. We're looking for t, so you got to leave t as t. Okay, and then everything is divided by r over m. Okay, so here is your initial setup. Okay, all right, so we've got an exponential equation on our hands. We've got to get t out of the exponent, so we're going to follow the usual rules that we've been following to free t from the exponent. Okay, so remember what you want to do first. You want to identify the quantity that contains the exponent. Okay, so what is being raised to the negative 12t power? This guy that I'm boxing in red. Okay, so our first step is getting this guy isolated. Okay, so we've worked with this formula before as far as solving for time. Okay, so think back to the steps that we did to accomplish getting this guy isolated. Okay, first thing we're going to do. Okay, all of this stuff in brackets, that stuff is like 1 unit. Okay, what's outside of the brackets? The 100. So we're going to start by getting rid of the 100. 100 is multiplied by all this stuff in the brackets. So to undo that, we're going to divide by 100. Okay, whatever you do to one side, you have to do to the other. Okay, so then on the right, this would cancel with this. Okay, if we go to our calculator, we're going to punch this in. So this is going to give us, let's see here, we're going to have $2,487.56. Okay, divided by 100. Okay, so that's going to give us this. Okay, so let's write that down. So we're going to have 24, oops, use a different color. All right, so we're going to have 24.8756. You got to carry all the digits. Okay, on the right, the 100's canceled and you're just left with what's in brackets. Okay, so we're going to have this is what's left. All right, so again, write everything down. Okay, baby steps, you're less likely to make a mistake. Okay, all right, again, what am I trying to isolate? This guy. Okay, so in the next step, okay, that stuff that we're trying to isolate, it is in the numerator. It is married to this one right here. Okay, so we can't break the numerator apart yet. So let's go ahead and get rid of the denominator. Okay, since we're dividing by r over m, the opposite is to multiply by r over m. So we're going to take both sides and multiply by r over m. Whatever you do to one side, you have to do to the other. Okay, so let's do this. It's a little squinched here. Okay, but on the right, you're going to have an r over m in the top and 1 in the bottom. They will cancel out. On the right side, you're going to be left with just the numerator, which is 1 minus 1 plus r over m raised to the negative mt. Okay, all right, we can go back to our calculator and update this decimal. Okay, so we're going to go and take this 24.8756, multiply it by r over m. Okay, so let me see what that was. This. So we're multiplying by 0.2499 divided by 12. Okay, got to carry all the digits. If you want to try to convert this to a fraction, I'm not sure if it will, it won't. So you're going to have to carry all of the digits here because unfortunately this is not a decimal that will convert to a fraction, okay? Not all of them do, okay? So let's write this down, okay, for our notes. So we've got this decimal on the left. All right, so keep going, still trying to isolate this guy, okay? I want this isolated, okay? Remember, this negative sign right here, it is outside the parentheses, so it is not raised to the negative 12t power, okay? All right, so still trying to isolate this guy in the red box, okay? You've got a positive 1 minus this stuff, okay? So you're going to have to eliminate the 1 next. The 1 is positive, so it's like being added, okay? So we're going to have to subtract 1 from this side. 1 minus 1 will cancel out. If you subtract 1 from the right, you're going to have to subtract 1 on the left, okay? So let's do that. Okay, so back to our calculator. Okay, we're just going to take this previous answer and subtract 1. Okay, that's going to give us this negative decimal. Okay, when you're solving these formulas that have the negative exponent and you're solving for time, you've really got to pay attention to your signs here. Okay, because they make a huge difference. Okay, all right, so let's write this down. Okay, so we're going to get negative 0.48196563, okay, is equal to 1 minus 1. These guys canceled, okay? Careful here. On the right, you are left with the negative sign out front, okay? Then the stuff in parentheses, okay? All right, so here we go. We're almost there, okay? Again, you're trying to isolate this guy, okay? So you have to get rid of the negative in front, okay? Luckily, both the left side and the right side are negative, okay? So we're just going to make both of them positive, okay? And so now we have this quantity isolated, okay? So I'm just rewriting this, okay? This is where we should end up, okay? So now that this guy with the exponent is isolated, okay, the next step will be taking the natural log of both sides. Okay, so let's go ahead and do that. Okay, so we're going to have the natural log of this side, and you're going to have to carry all the digits, is equal to the natural log of this other side. Okay, and the natural log is what is going to allow you to bring that exponent down. Okay, so now we apply the property of logarithms. If I have the logarithm of something to a power, we're going to take that power and bring it down in the next step. All right, so we're going to have the natural log of this decimal. Whoops. Natural log of this decimal is equal to negative 12t times the natural log of 1 plus r over m, okay? And the exponent is gone now, it's come down, okay? I'm out of room here, okay? I'm gonna continue on the next page. Remember, when we're solving for time, we want to solve for m times t, not just t, okay? So I am gonna solve for this quantity, negative 12t, okay? So what I'm gonna have to do, negative 12t is multiplied by this logarithm on the right, okay? We're going to have to divide both sides by this particular logarithm. So let's do that in the next step. All right, so on the next page, I am just going to rewrite what I had, okay, just so we can kind of make sure we're writing things down correctly here. So I had this logarithm equal to negative 12t times this logarithm. Okay, and we want to isolate the negative 12 times t, okay? So we're going to have to divide both sides by this logarithm, okay? All right, so now we're going to have to go to our calculator and divide these two logarithms. On the right side, you're going to have this logarithm canceling with this one. That is going to leave you with the negative 12t, okay? All right, so off to the calculator, let's input this. we're going to have the natural log of, and I'll just go ahead and enter it in because unfortunately I cleared things there. So 0.48196563, close parentheses, divide by this other logarithm, okay? 1 plus 0.2499 divided by 12, okay? And out comes our decimal, okay? So remember, we are solving for time, okay? So this is not dollars and cents. So let's write down this number and then talk about it. All right, so I've got negative 35.41206.573. Okay, so like I said, we're solving for time. This is a time number. Okay, so remember, time cannot be negative. That doesn't make any sense. And you see that this 35 is negative. Okay, but look at the other side, the right side. Okay, you have also a negative number. Okay, so you have negative 12t on the right. Okay, so what will happen, luckily, your negatives will cancel. So if you multiply or divide both sides by -1, both sides will become positive. Okay, and so now time will be positive. Okay, so that makes sense. Okay, so now we have to round time. Okay, so when we've done solve for time in this chapter, okay, there have been, in most cases, we have rounded up. Okay, there was one situation where we had to round down. Okay, so remember the difference between the two. Okay, if you are saving money, okay, you want to round time up just to ensure that enough time passes to accumulate the amount of money that you're trying to accumulate. Okay, the one instance we saw in which we had to round down time was when we were withdrawing money from a retirement account. Okay, because in that case, the whole part of the number was referring to how many full withdrawals could be made from the account. Okay, this problem is a little bit different. You're trying to pay off a credit card, so try to apply just, some everyday living to this kind of situation. Do you think you would round up or do you think you would round down? Okay, so if we're trying to pay off this credit card, okay, it's in our best interest to round time up just to ensure enough time has passed to actually pay off that credit card bill. Okay, so we're going to leave the right side as 12t, okay, and we're going to bump the positive 35.41 up, even though this number is a 4, we're going to round up to ensure that enough time passes to pay the credit card up. We'll bump it up to an even 36, okay? All right, so now we can interpret our answer. Remember, the 12 in front of the T is referring to months, okay? So the answer here, it's going to take 36 months to pay off the credit card, okay? 36 months, since there's 12 months in a year, okay? That's also 3 years, okay? So this is going to be the amount of time needed to pay off this credit card. I'll put credit card debt by just making the minimum payment. And that is how you do this problem.